Okay, thanks everyone for joining. We'll take an hour or so to speak about some interesting topics about Crystal. This is the 5 years anniversary of the 1.0 release, and I will give this mic to my colleague Johannes to do the proper introductions.
Yeah, right. We're here because 5 years ago there was a big release, Crystal 1.0.0. And it was like a big point in the history of Crystal, like a lot of work that went in it before and a lot of it work that happened afterwards. And we're here to look back a bit about what was the situation with or at the time of 1.0. And what developments have happened since then. I'll just have a very, very short history of the language. Just when it came to 1.0, there was the question like, when is this gonna happen? And then there was this kind of decision, okay, we're gonna define some things that can wait after 1.0. So those are things that we don't need to worry about for the release. These are mentioned in a blog post. But this our Windows support. We knew that's something we can add after 1.0. Debugger improvements, that's all stuff we can improve. Multi-threading support. It was clear that this is not going to happen before 1.0, but all these things can happen, like enhance the language after 1.0 gives some stability guarantees. And of course, like lots of compiler bugs, other issues that can always be fixed. So that they were not a blocker for 1.0. A couple of other things were blockers for 1.0, but it was mostly cleaning up. And if we look at the highlights of the 1.0 release, it was removed some deprecated features, cleaned up house to throw out stuff that we didn't want to support in the future. And two, I would say, rather small feature enhancements that were just, some progressive enhancements along the way. And other than that, Crystal 1.0 was not a big release in that sense. Like, it was just similar to the previous release, 0.36, and just a stable version of that. But what actually 1.0 meant is a whole different story. So the achievements that having that 1.0 name brings is stability because people can expect their Crystal code to work and not break for all versions of the 1.x series. And because we guarantee that's the backwards compatibility since 1.0. It's also a bit more predictable. We have a clear release schedule. Every 3 months, there's going to be a new minor release of Crystal. So that solves lots of issues with wondering about when is the time to make a new release. Is there enough features or enough bug fixes or whatever? It just happens on a regular basis. So continuous improvements. And the 1.0 also helped with scoping things. It was clear, okay, this is stuff that needs to go before 1.0, and afterwards we have stuff that we can work on that enhances with the backward compatibility in mind. But it also means for now we're maybe not prioritizing things that would break backward compatibility because that would leave some of that stability behind. I mean, this is gonna happen eventually, probably, but maybe not in the immediate the future after 1.0. And for the past 5 years, we've kept that backward compatibility as good as possible, at least. There's sometimes bug fixes which may break stuff, but that's just unavoidable, I think. And what happens since 1.0 in these 5 years is actually similar to what we said is what can wait after 1.0 is Windows support. I mean, we're pretty far with that. Not fully 100% tier 1 support, but basically working for a long time actually. We have improved debugging capabilities, tracing, and all this stuff. Multi-threading has been much improved since 1.0. This is one of the biggest things we are currently working on. Compiler bugs have been fixed, lots of them, I think. And apart from that, we have also had other changes, of course, but the language itself has been pretty solid and not changed that much since 1.0. Looking at a couple of things, we got a lot of platform support. Some things we didn't even think about maybe at the time of 1.0. But yeah, just made it more capable where Crystal can run. The interpreter was, I think, a big surprise as a completely unexpected platform. And the others, of course, with a lot of help from LLVM, we don't have to do that much for a new hardware target, but still having language support and also Synlab support for new targets, especially new operating systems, is always a challenge. I think Android and Solaris are particularly interesting because they do many things differently than other Unix operating systems that we used before, like Linux, Mac OS, and the BSDs. So that was a good challenge to see how portable our stuff really is. And some other feature enhancements in the language. We have autocasting now. I think that's a really convenient feature. 128-bit integers, improved portability of standard lib APIs, for example, in the process status and process handling. Compiler tools and tooling in general has improved. The lifetime event loop is a good improvement that we had. It's just more efficient than lib event that we used before. And I'm sure there are many more things. Maybe we'll talk about more of these things in the following minutes. But that's what I consider some of the highlights. And yeah, now I'm happy to start into answering any questions that will come along. And I hope you're all excited about 5 years of Crystal and a stable Crystal and many more years to come, I hope.
Great. Thanks. Thanks, Johannes, for that introduction. And now that we are on this retrospective perspective, sorry for the confusion there. That's a question for any of you. Just take the mic and start. What would you say that is the most significant feature since 1.0 until now?
I can take the first stab at it. I would say that Windows support is the one that requires a lot of love, and we are pretty far. We are, as Johannes mentioned, we are not at the point of saying this is ready, but we are almost there. And in the next month, I would expect it to be even tier 1, as he said. So yeah, I will go with that one.
Can go next. I'm not on the core team. I'm working at the company behind LavinMQ. I think it's probably one of the biggest production code bases written in Crystal. And we've been building on Crystal for a long time, since 2017, and been sponsors for a long time as well. So we're very committed to the language. And from our perspective, I would definitely say multi-threading has been the biggest one since 1.0. Yeah, it really allows us to take our software to the next level.
Yeah, so thanks, Anders, for introducing yourself. That made us realize that we didn't introduce the guests here. So yeah, as you have said, this Anders from 84 Codes, our main sponsor, and also responsible for LabNQ. We have also, I will just read ahead of what I see in my screen. Julien Portalier, core team member and Manas employee. Beta Ciliani, ex-Manas employee, core team member, lead the Crystal team for a while, until a few months ago. Johannes Müller, actual lead of the team and also core team member and Manas employee. Jamie Gaskins, it's a crystal enthusiast and powerful collaborator. Brian Cardiff, again, a founder of the language and ex-Manas employee and core team member. And Margaret, core team member as well, and doing super interesting work on crystal tooling. She'll likely have some time to speak about that in the next few minutes. Sorry if I missed some details on that. Feel free to do a proper introduction if you like. But if not, we can go into our next question. There was
let's
please,
continue with the highlights.
of course.
I think we just made 2 people there, and maybe others would want. I would just want to jump in that I think Windows is important, but also AH64 support, because realistically, most users on Mac nowadays have AH64 CPUs, so supporting that natively is probably a very important feature.
Absolutely.
Okay. Well, of course, we'll be able to come over to these topics again as they appear in the conversation. There were a few questions on the Discord channel. One of them is related to compilation times. It's from, well, I don't know if I will say this name correctly, but it's Kojix2. Is slow compilation really caused mainly by the lack of incremental compilation, or that's an assumption wrong to begin with? I don't know if Johannes or Julian would like to take this one.
I think, I mean, we don't know for sure, and like, because we can't test it without having incremental compilation to see what impact it has. I think incremental compilation would probably have a big impact. But there are probably also many other things we could improve without incremental compilation. Just making the compiler work more efficiently. I think there are many angles where improvements would be possible outside of incremental compilation, because incremental compilation is a very complex thing, I think, because the language is not necessarily meant for that, or like the design of the language makes it very complicated. So having other angles that are maybe easier to reason about is certainly a good path where we can reach performance improvements.
Yeah, I completely agree on that. For real absolute performance, yes, likely incremental compilation will be needed at some point. But Crystal is, the design of the language makes it kind of difficult, or more difficult. We can't just build a module, and no, because any change anywhere can change anything anywhere. So But yeah, and there are lots of smaller, probably, but lots of optimizations in the compiler that we can do to do less work, less allocations, less things, which will make it a bit faster.
Yeah, and to I don't know, currently what we do for faster compilation is basically caching the bit code, the bytecode, so it's not compiled, right? And just that was a great improvement when it was introduced very early on. But there are still ideas that haven't been implemented there. Just like, for example, to mention one concrete example is like when you do the multi-dispatch that is very, very present in Crystal, that invalidates a lot of the bytecode because how the methods are dispatched over a union affects greatly. So shaping differently the bytecode could lead to better utilization of this caching of compiled units. So there are still some tiny ideas that could lead a lot of performance without changing the language. But also, like, we always talk about like how the balance between the language design and how it makes it harder to do incremental compilation. And another term that appears, incremental versus modular compilation. Like for me, incremental is about like reusing everything that happened before and do little patches to make it useful for the new outcome. But while modular will allow you to identify different units that could be reused as a whole. And I think similar as like type inference allows you to have types without needing to be explicit. Maybe there are some like compilation unit inference that we can have to say all this is code that is unchanged by the application, and then we can compile it in a different way. There are different ideas that could boost better developer experience, I think. But those are unexplored, and some might require some compromises in the language, some don't, and we are always very afraid of how to do those changes without being disruptive. But well, that's the current state, and I think it's there's still some promising ideas to come.
Great. And now that I have you on the microphone, Branch, there's a question that might fit for you. It says, if Crystal sets smarter boundaries for object file generation based on which type are explicitly declared versus inferred, can it make better use of caching? I think that you already mentioned that, but just to answer the question specifically.
Yeah, it is not like comparing to other languages where you have a very strict interface defined in modules, that helps to define boundaries of compilation, like from C headers files to having clear interface. That is a way to establish explicitly the boundaries, and some of the core team members thinks that could be a way of the language to evolve to achieve that, but affecting the nature of the language greatly, because if we enforce, like at the very beginning, before 1.0, even just enforcing type annotations on instance variables felt like a huge deal, and that was way before 1.0. But we survived that. Like, okay, we could change the language, and it's still fun to use. Whether enforcing type annotation on every method, that seems a little bit more risky to me. But I think my perspective is that when we have a rich code base, there's a lot of like standard library code and there's application code. And it doesn't make sense that when we change an application code, a little method, we need to rebuild or reanalyze all the standard library. So I think there should be a way to draw some boundaries there based on utilization. It's harder. Beta, I see you. But I don't know, that's my gut feeling says that maybe having some boundaries should be possible, and that doesn't need to be as intrusive as type annotation in every single method. I think there should be something in between, maybe affecting other parts of the language. Maybe the global namespace is the stopper for there. But I don't know, this is uncharted territory, definitely, and it's great that we I would like to see us explore a little bit of those ideas, even if those result in failure experiments. But so far, we have always been focusing on shipping, on developing things for shipping rather for exploring. And now that we have some good big features landed, maybe it's a time for having some exploration, and that exploration could end up in not successful result, but that is still a successful outcome, but it will not be in the compiler. So I don't know, as a community, maybe that should happen as a next stage.
Super. Thanks for that. So shifting a bit, just to get other voices around, there was a question about type safety. It says something like, do you think Crystal or another language in the future could do the same Crystal did for type safety without need of many annotations? Do the same for thread safety and concurrency? Beta, I have your name there. You're a shy guy, but I guess you can take this one.
I can take that, yes. So, well, the first answer to that is there is a language already that is having a type system to have safe concurrent code. Rust has that in since the beginnings, was part of their design goal of the language. So we are already in that future in which languages are using a stronger type system to help you write safe concurrent code. Now, when you think of Crystal, one of the criticisms I have for Rust is that the type checker is a bit strong in the sense that you have to fight it a bit more. One of the things that Crystal does is the opposite, is you write code, and if the code makes sense in terms of types, you're free of having to be explicit about the types and everything. We can think of, well, maybe we can give a spin to the Rust idea, but the Crystal way, analyzing the program and making sure that there's no concurrency bugs. But I think that will be, first of all, very expensive. I mean, already we are talking about the type system of Crystal being expensive to check. If we add more stuff to it, it will be more expensive. But you can think of it more as a linting tool, linting tool to check. After you have your code, it seems to work, then you run something else that checks and makes sure that you don't have concurrency bugs. That is something I will see more appropriate for this kind of goal, I would say.
I also thought about Rust right away. And I think like the implementation that Rust has for concurrency safety in the type system shows that this is really hard to do well. And then it's hard to use. Like it's not very friendly. I think the Rust getting into Rust requires a lot of learning how the type checker works. And I think that contrasts a bit with the idea of Crystal being easy to use. Of course, having safety is also an important feature besides it being easy to use. But at least I would say that the Rust way is not ideal for the Crystal idea, I think.
Yeah, I agree with that. It's in kind of tying it back to what Brian was just saying a couple minutes ago, how like the sheer amount of syntax involved in the way Rust handles that concurrency safety is something. If we can't, if people are going to object to adding type annotations to every method, are they going to be okay with adding all of these other sigils onto each variable that they pass into into every method, is that something that people are going to want to do? And my gut feeling is that no, they're probably not going to want to do that.
I know I don't want to do that.
It also wouldn't be Crystal anymore, I think. We can do better to improve the situation. We can do some things in the compiler and the standard library to improve overall thread safety by default. And as Beta has said, we can have a linter that would analyze the code, do a full semantic pass, and run more semantics and more analysis, slow ones, that would analyze and tell you there is a bug here. Maybe it won't catch everything, but it could definitely help.
Okay. Well, it seems that we have rehearsed this because I had a question for Julian. It's about multi-threading. It's a bit long. I'm pretty sure you have read that, but I'll read it aloud for everyone here. Well, when multi-threading make it to our platform, would there be a clean way to specify channels or fibers are to be used on real threads rather than coroutines? Example, one channel of fiber on a real CPU thread, and another on another thread. This would give the best of both worlds with concurrent stuff on parallelized context. As far as I can tell, there's no way to do that currently, and it would be a nice feature to have.
I think that's the whole point of the new execution context that are we are polishing. Well, the feature has been implemented. We're not releasing it yet because there are still some few bugs that we need to squash to be able to say Crystal is empty ready, empty safe, and so on. It's coming very soon, but not just yet. And the point of execution context, it's been very influenced by Kotlin, where you can now say, yeah, I want to start one thread that will execute a number of fibers concurrently. I even want to just start one thread and make sure that there is only one fiber running on it. But by default, we go the Go way. We want to have a parallel environment with possibly one or many threads running your fibers and scaling automatically, so you don't have to think about it. Your fibers will run on many threads, and that should be efficient usually. And for very specific cases where you need to, you can isolate a fiber to own a thread, and you can do whatever you want on that thread, and that won't block anything else in your program. Or you can decide to start multiple contexts and take advantage of thread preemption, where the kernel will stop running a thread and switch to another one, because you want to have different behaviors. So yeah, this is coming.
Yeah, and you can already check that out. Like there's a preview. The preview feature is available since I think 2 or 3 releases already. So yeah, just check on the execution context compiler flag, and you'll get that. It's also in the API docs available.
Yeah, Beta, please.
And I just wanted to add that a reminder that fibers are much more efficient when you are, for instance, reading a socket or things that involve the operating system and waiting for files, whatever. That's much more efficient than having different threads, because each thread is a much more heavyweight object than fibers. So this is a reason why fibers exist and why they're so popular. But yeah, I just wanted to add that bit.
Actually, even for CPU-bound fibers, with the parallel context now, and work stealing, the fibers will scale across many threads and across all your computer cores as needed. And it might be, in my own testing, it was more efficient to just start, like if you have 32 cores, start 32 fibers to run in one channel and one producer and 32 consumers. It's more efficient to just start a parallel context and let the runtime scale everything on your computer rather than start many isolated fibers or multiple concurrent. Things will scale much better. But in some cases, you might want to have control, or you might prove that you have better performance, or you want to have constant performance over your cores, and that's possible.
I didn't realize that the execution context implemented work stealing. That's fantastic.
Yeah, there are lots of nice features that the current scheduler does not do, but execution context schedulers are capable of. So yeah, I think it's gonna be a big thing. We expect that to land probably in the next release, or one after. Next one is already happening soon, and
Yeah,
it should be soon.
Sorry, 1.0 is a bit too short. We're entering freeze in 1 week or something, just to enable the feature. And I'm squashing one last bug right now.
Yeah, this has been terrific work, Julian. I think we can really say that here and attribute most of the heavy lifting for execution context. That's all you're doing. So thumbs up.
Thanks.
Yep. So moving forward, let's get some other voices around. I'll go with a general question for anyone who wants to answer. What would you say are the long-standing issues Crystal has that you would like to be solved as soon as possible? Please pick one or two at most.
I have one some take on that. Maybe a bit more abstract, but the latest releases, although we're focusing on bug fixing the compiler, it was more about the language itself has been stable, right? So at some point, I think that we should either decide if the language is done or it should keep evolving. It's an open question, but I probably think that it should keep evolving because we will discover along the way things that we want to do different. That has happened since the beginning, and I think the compiler as it is today is hard to make some of those evolutions without being disruptive. So maybe we need to put some solid grounds there to allow things to evolve in a better way. Two of the main examples that I will follow in the other languages is either Rust additions or Haskell language extensions, how they evolve. But that requires some massive undertaking on how the language and the compiler is currently shaped, which can open the door for other improvements, like better tooling support, better compilation types, better interpreter or debugger. All those could align in a different organization of the compiler. But the organization itself, it doesn't give us some outcome, some perceivable outcome. So it's hard to invest in that. But those foundations, I think, are some remaining challenges to go and to find how to do that, especially with the open namespace and every code loaded together and smash it together to get the compiler, the compiled program. It's harder. So we need to go into the whiteboard and design the foundations there, I think, a little bit. So not concretely, but strategic concerns.
I can just add a couple of words on that as well. Like the most common feedback we get when we onboard new developers onto our Crystal project is around the developer experience, things we already talked about, like compile times, the lack of a full-featured LSP, and like introspection tools, debugging memory usage and stuff like that.
Just to add that the compiler was started before LSP was a thing. Definitely will shape the compiler differently nowadays. So we are young, but not that young anymore. And I think the initial tooling for watching the context and to try to get some introspection of what the code is being perceived by the compiler were more experimental things. Like it's like, yeah, we can do a atom extension that will show this in a nice table. And because we could do it, we started that, and then doing the reachability tool, or where this method is called. Like there are all things that should be doable in a compiled static language, and we started with those using the foundation that we have, which were not the fastest one. So it's not that they were really thought to be fast. I think it's more about like, is this tool useful or not? And that's something that we, for reasons they are not in the compiler, we don't have like instrumentation on what is the feature of the compiler, or which are the features of the language that you use more. We rely that on the community to be vocal about that, because it's not that we want to report metrics somewhere in the server like, hey, someone is using your tool, for the formatter is being used like 20,000 times a day. And we don't want that kind of thing in the open source compile. But we need the community to be able to weight which are the tools more useful probably, and to design around those, I think.
Makes sense.
I think one of the challenges for LSP support, I don't know, Margaret, you can maybe tell more about that. But one of the challenges of that is similar to the challenges with incremental compilation, that the design of Crystal makes it hard to calculate these things efficiently and keep state and keep track of changes in the program state.
Yeah, there are a lot of issues with Crystal that stand in the way of having like a really good language server. Compile times are one, but there are a number of ideas that I have for doing like different kinds of semantic analysis, potentially to source code. And we have stuff now like the tree sitter compiler, which is fault tolerant out of the box, so we could maybe utilize. So progress is being made.
Okay. So let's move forward. There was a question on Discord about the places in which we manage shards. If they asked if there were any idea of doing what Ruby did with Ruby Hems or something like that to move forward from the current state. Anyone want to take this one?
I can't speak for the core team, but one thing I will say is that, you know, because there do exist some kind of like registries. You know, people have made some like we got Shardbox, we got shards.info, Crystal shards dot something, and having those is a very different thing from something like rubygems.org that has a central package repository. Once you start doing that, then you have to start thinking about things like hosting. How are you going to store all those packages? How are you going to when people download them, you have to pay for that bandwidth. How are you going to pay for the bandwidth? Then you also have to think about things like moderation, and security. How do you secure that package ecosystem so that people aren't injecting bad packages? And if a bad package does go live, how do you pull that? Things like that. Those are things that are much larger than and require a lot more resources, both human and monetary, to handle. Right? You have to, and it requires ongoing effort, especially on the security front, because security is a bit of a leapfrog game. Like once one side gets better, the other side finds new ways, and then you have to figure out those. And it's just constantly back and forth.
Yeah, to add into that, like from the beginning, I think it was Wash who pushed more for a decentralized package repository. It was a little bit like different from what we used to have at the time in other languages. But I was very happy that we did need to invest effort in all the challenges of having that. And but definitely, like, well, in every other language where you have a main repository, the transition to a different one because things change, well, it's harder, right? Like you are inserting issue transition from shards 1 to shards 2, like how it is disruptive. So by not having one is avoiding that disruption. It also honors, I think, that at the end of the day, it's about you trusting other authors of packages. So having a decentralized force you to choose your packages based on authors. And it's something that sometimes is hidden, like because it's something is pushed and you get there first and you got the name. Well, is that the official one? Now we have had some struggles with whether the packages is in the Crystal Lang or Crystal community or some other author like that give you some level of I don't know, a badge or something. But definitely sometimes it also put a lot of stress on us as consumer of packages. Like what happens if the author goes away and removes their organization in GitLab or in GitHub? Like that dependency is gone. You lose that guarantee, that safety net that a central package repository could offer. So maybe there is something in between of how to enforce that. And maybe the tooling could be a little bit more robust to support those cases, like packages disappearing. Like it's like definitely you can fork and have your own copy, but there is no like a convenient way to offer, I don't know, a proxy, a mirror, a relay of Git repositories. And that could be something interesting in tooling, especially for, I don't know, for companies consuming that they want to guarantee that their dependency chain will not go out it won't become unavailable on a whim, right? So I think there's still room for room, but I'm very happy still with the decentralized. And also every single language, the first question that you have when you have a package is, how do I put my own fork there? So you always want to open the door for other sources. You need to open that door. And we have that door open from the beginning. So I'm pretty happy with that. I think it's more simple in that way when you understand how things work. So yeah, still vouching for decentralized, I think.
Yeah, I think like many improvements that you mentioned are possible without having like a really central registry. Just having an index like Shardbox, which I built to have a kind of place to see what's there. I mean, it could be, for example, could be easy to integrate some feature that offers alternatives when a source is unavailable. Then Shardbox, for example, already knows about some repo duplicates or mirrors, basically, or yeah, could also know about shards that are dependent or derived from one another, so hard forks, kind of that thing. And that could be integrated even in the shards binary in some way, that if a upstream is unavailable, then could query an index and offer alternatives. But it probably shouldn't happen automatically, unless you have a very trusted index.
Having a central repository, it's nice that solves many issues at once in a cohesive way, that you have discoverability, you have availability, and you might have security concerns all mixed up there. You can divide and have tooling attacking each of those concerns, but we need some better integration, so they are not like you don't need to hunt from one to another. So maybe there needs to be some collaboration around toolings to offer a better developer experience, even if the concerns are separate and managed by separate entities. I don't know. We can dream.
Yeah, and I mean, one of the ideas for like having not a central index is just to put all everything in one place, where if that thing fails, you get nothing. But I mean, realistically, most public shards are still hosted on GitHub. So if GitHub goes down, then all sources are unavailable. Yeah, but I don't know. I've come to think that maybe it would be a good idea to have all your dependency in your own repo. So you only need to pull from upstreams if you want to upgrade a version. So then it makes sure that you always have some compatible code available, even if you don't have any connection to wherever the upstream is.
Yeah, and what we're doing for Crystal and shards is that dependencies are checked in. So we just put the lib folder into the repository itself. So even if the remote disappears, that will break shards, but you still have the code.
And it's amazing that nothing of this depends on the language. It's totally agnostic of the language. And it's like just that we want to do things slightly different because things we think it might lead to a better result. But it's amazing that this problem that is in our language, like we want to have our own solutions.
Cool. So let's move forward into some slightly boring stuff. There was a question about finances. I'll try to answer shortly, and then we'll move into more interesting things. So to speak broadly about Crystal finances, I would say that we have a great sponsor, that's 84 Codes. That's our main sponsor and funds most of the work we're doing. That those funds plus some sponsors we have on Open Collective plus something in GitHub, especially thanks to PlaceOS there. That's one of the big sponsors on Open Collective as well. Allows us to have 2 devs working almost full time. So that's great. Of course, we always dream of more, but that allows us to get here and to be stable as we are. And now that we have Anders here, if you want, would you mind sharing a bit what are the motivations behind 84 Code's decision to sponsor Crystal?
Sure. Well, it's a kind of a unique language. It's very performant. It has a small footprint, and it's also super nice to work in. And we jumped on the train early, and we've been happy developers since. And I think we've proven it with LavinMQ, and we're betting hard on that. So we're gonna continue bet on Crystal. I can't speak to if the budget for Crystal is sufficient. Of course, more would probably be better. Like other languages have basically unlimited funds that are backed by Google and Meta and so forth. But at least for us, Crystal is we see Crystal as a competitive advantage and not a risk. So we're gonna keep betting on Crystal.
And I think it's really encouraging to know that you started development on 11MQ even before Crystal 1.0. So that's been going on for over 5 years now. even without the stability at that time.
Yeah, we had software on Crystal in production before 1.0 and had paying customers on Crystal software before 1.0 as well.
Okay, so now we can turn into something that might have everyone's voices around. I think that the main opening question would be, what are the things that are holding back Crystal adoption? What can we do to get Crystal to do Crystal a more popular language?
Honestly, I think the biggest one is tooling. Like if somebody's coming from like TypeScript or C# or other more popular languages, they open up their editor for the first time, install the official extension, and then there's just like no language server support at all, no errors while they're typing. It just is a very poor first experience, and I can see that losing like 50 to 90% of people just on that. So that is probably one of the main things holding people back, at least that I can speak on.
Yeah, I didn't realize how many people use language servers in their day-to-day development. Mostly because I don't, and so my assumption was that it's probably not that many, but so many people I talk to do use them in all their development. So that may very well be a common blocker for folks.
Yeah, and it's easy for like us Crystal enthusiasts to like push back it because we love the language, but other people who may be on the fence, that's going to be something that pushes them away versus pull them towards.
So I want to add to that point, which is very good, that also the number of libraries. So when you want to today, when you start with whatever script, TypeScript, JavaScript, or C# or whatever, Java, Ruby, you have tons of libraries. With Crystal, we have, I think, 10,000 shards. I don't know how many of them are active and still working. So that's also definitely something that you want to do something, and then you realize that you need to build first a library. And I think one of the aspect of people misses is that all popular languages have a very strong company backing them, and that means also building libraries and stuff. We don't have that, so we have just the community, and the community is wonderful, and it's creating a lot of stuff, and it's exploding thanks to AI, because porting from Ruby using AI is quite simple. At least that's what I hear from the forum. But you cannot compete to the power of one of the big tech companies in that regard. So we need to get the attention of one of those companies, basically. Yes.
It's true. The ecosystem is the ecosystem is pretty decent. There are a lot of the more common use cases are covered by the Crystal community. One of the things that a lot of folks may also be looking for is official support. Like, for example, Honeybadger has an official like first party Crystal library, but a lot of other companies, a lot of these service providers don't have, Crystal is not in their list of first class languages. Like they've got the Java, the Rust, the JavaScript, TypeScript, Ruby, Go, but they're Crystal is not in that list typically. And so we have to rely on community support and third party shards for it. For various things, which may or may not support the use case that you are trying to use, like, because it may only implement a subset of the APIs that you may need. So it does require a bit more community involvement in the development of those shards.
Definitely, like not being 1.0 was a big stopper for that to happen. Like no company will create their own SDK, their own client library for a language that was 0 point. So, well, we unlocked that 5 years ago, and maybe though I don't feel comfortable saying that all the code will be written by LLMs going forward, but some client libraries I think are maybe a good example where LLMs will shine because the API is porting from one language to another, and LLMs might be slightly good to unlock that. Maybe not with the most idiomatic code unless you train it. So, but maybe we are in a place where those can start happening. I recently I experimented porting the MySQL connection handshake, which is something I was like, hard to get the motivation to do it, but to be reasonable work. And I also discovered that MySQL Pascal package did the same. Used Claude to get the MySQL 8.0 handshake. So it was the same feature implemented in 2 very different languages with the same tooling. And well, maybe it's a case for that. And I don't know. A couple of years ago, I was also thinking that in order for the community to pick up on the packages, like we wanted to avoid fragmentations, and that's why the standard library is maybe bigger than other languages. But having some fixed like APIs for some concerns is something that we wanted, because we wanted to avoid the like dependency hell of various way of doing the competing responsibility. In that, I was involved in either the DB API, which is not an ORM, but it helps you to build whatever ORM on top of that. So I think that was a good. And the other is the logging, for better or for worse, you like it or not. I was involved on that. It has some quirks, definitely. But I wanted to have like a standard, a crystal way of doing logging that could be shared across. There are other concerns that maybe haven't surfaced yet, or shards were not positioned as the official way, maybe because it was not in the Crystal Lang organization or in the Crystal community, and it's harder to build like the trust to say, yeah, this is the way for doing, I don't know, configuration, right? There are very, very good shards with very good ideas, but we need to kind of endorsement or somehow as a community recognize, like, yeah, this is the way we want to do it. Like, we are all enthusiasts, and it's harder for those to pop, right? The community is smaller, and also it's more made of individuals rather than companies. So I don't know. I think we need to I don't know, find good example of those and have some stability and say, yeah, we want this API going forward, even if it's not a crystal lang. Like we need as a community to say, yeah, this is the good solution that we want to go and start building from there. Like in Ruby, you have rack, which is not in the standard library, but all the web servers do that. The HTTP server in Crystal is good one, but it's not the best abstraction to build frameworks on top of that. Maybe we need another layer so different frameworks can be mounted there. I don't know. Maybe it's a bad example, but there is a limit that what the standard library should do. It's already doing a lot, and we can't do the right abstraction for everything. Like file system, do we want abstraction file system? It's like, well, virtual file system is a nice feature. Do we want it in the standard library? Maybe that's a line we need to draw at some point. Interesting problem, love it, but we the Crystal just and I will shut up with this. Like the Crystal DB, when I started developing, I thought it was going to be in the standard library. I even developed that as part of the standard library. And it's like, no, you can't have us. And I have all these commits in the compiler. I want to have it there. It was very early, but it was good to put it in a separate shard. But well, we made that. So things can be established the de facto standard, even if they are not in the standard library. And that will help the community move forward, I think. Sorry, longer speech.
Oh, that's really cool. So I will try to mix up two questions into one, just to get better use of time, because we been talking for an hour already. Regarding Crystal adoption, there were kind of two questions there. One is related to the relationship with the Ruby ecosystem. What would have happened if we had another relationship with Ruby? And another one slightly related to that, but not totally. Are there some marketing strategies or efforts we can do as a community to raise Crystal popularity?
I can start. I would say, so the first thing is there are two tools to bridge Ruby and Crystal, one in each direction, that I think need a bit more of love and popularity, or gain a bit more of popularity. I barely tried them, but that's something to look into in order to have a better interoperability with Ruby. That should be a good goal. I mean, for obvious reasons. And if we can show that we have this interoperability, maybe we can easier market Crystal to Ruby developers. When I see a Ruby developer saying, I needed performance on this particular topic, so I went to Go, my heart crashes. And it's like, no, you should have gone to Crystal, right? But then all the other topics that we mentioned already, like library support and so on, make them think of Go instead of Crystal. So the idea will be, no, when you want to have safety, speed, and so on, you can use Crystal.
Yeah, I think. No, go ahead, Jamie.
I was going to say that's actually something that I tell people on a pretty regular basis. It's like if you're using Go or Rust because it's fast, sometimes you maybe over something like Ruby, like you could also use Crystal, and sometimes it'll be faster, even than the Go or Rust. Not always, but sometimes.
Certainly, it's closer to the heart if you're a Ruby developer. And I think Crystal is, I mean, relatively well known within the Ruby community. I mean, definitely more than other communities. And I'm thinking that like the direct integration as the between Crystal and or like Crystal providing functionality for Ruby, this is something where Crystal is maybe not ideal. I mean, there are these bridging mechanisms, but yeah, certainly that works. But also, like Ruby has, for example, since Crystal was invented, Ruby has gained a lot of improvements in performance, for example. So maybe that's less of a pressing issue for Ruby developers. I mean, certainly there are still workloads that cannot be offload, or that are so heavy that you want an efficient language to do that. But then you're always there are fewer maybe than many years ago. And those are probably often at like boundaries where you have a job processor or something in between, where you can just have some other tool process that stuff. So you don't even need a direct integration between Crystal and Ruby. And one other thing where I think Crystal is very useful for Ruby developers is when you have an API kind of thing, and you want to provide a client that users can download and install locally. Then Crystal is just so much better than Ruby because you can distribute a statically linked binary, and that's all. You don't need to package a Ruby installation with dependencies and whatnot. So I think that's really great benefit that Ruby Crystal can provide for Ruby projects.
I was going to add that if we have a more close relationship with Ruby, we might have a different languages because maybe we will focus on those instead of being an independent language, like how to integrate on that. Well, we have twist things a little bit and have our priorities. I do think that maybe we are not very versed in marketing strategies. That has been a constant in the project. And also another challenge is that there are so many decisions around integrating two languages that it's hard to have something that is flexible enough for other scenarios. Like, for example, at where I work now, we have this Rails backend and Haskell, and we mix them and we respond Rails requests with Haskell code in some aspect. There is a call by Brian Carroll that share how we are doing that, and it's great. And if we are integrating Rails and Haskell, we can definitely integrate Rails and Crystal. Like Haskell is big on runtime, it's compiled. Like there are many, like the binary aspect of those should be kind of shared. But I don't see that as being as popular, like framework or mixed framework, because there are so many decisions around that are shaped on how you use the framework that it's harder. But we could still like publish some things that are possible if others want to follow. But I see that as a challenge to have these two frameworks integrated. Like it's possible, but is your combination of all the because there are many questions. Is your combination of those answers fitting other projects that nicely that you will call, I know, Crystal and Rails thingy? I don't know. It's hard.
I can say a couple of words as well on this. The similarities between Crystal and Ruby has benefited us a lot. It's been first, we used to be a Ruby shop, or we still are in large aspects a Ruby shop. That's one of the reasons why we found Crystal in the first place. And I imagine it would have been a lot harder to hire and onboard people if it wasn't similar to Ruby in that aspect. And on the marketing side, I think when your company chooses to use like a niche language like Crystal, you also have to be vocal about it and promote it, because otherwise it's a risk for the company. If you build some application in a niche language and no one hears about it, and you're not contributing to like the growth of the community around the language, it's likely that that language would dwindle in adoption, and your software will be at risk of not surviving for very long.
Okay, so now we are approaching to our kind of last big topic, or so. And that would be perspective right now. So there are several questions with different shapes and words, but I think that most of them point to the same topic, and is how do we imagine the future of Crystal? One big question could be, what do you see in Crystal in 5 years' time? Or the other question, with more marketing, would be, what will be available in Crystal 2.0? Again, there are several questions, and we can divide them ideally, but it might be better to use this 15-20 minutes left to openly discuss what can be the plans for the future of Crystal. So whoever wants to pick that one and start.
From my perspective, we've talked about it already, like yeah, all the from compilations times to developer experience, and with the stuff that's on the way now with the execution context and so forth, I think we're going to be in a really, really good place. And yeah, going forward, just keeping up with new kernel features and gaining more adoption, I think is key.
Maybe there are explorations we could do into like minor changes we could change to like the syntax or semantics of Crystal that could make tooling significantly easier without Crystal differing too much. I think global namespace is one of them, but like in the parser side of thing, not having everything be an expression, or like changes to the macro system, different ideas to explore and play with.
Yeah, I think if we're looking at like the big question is like Crystal 2.0, when's that gonna happen? It's been 5 years since 1.0. Is it gonna take another 5? I mean, honestly, at this point, I have no idea. I mean, there is a kind of balance here between disrupting like the kind of backwards guarantee that we have. And is it better to do that in smaller steps where you just change a few things where maybe not that much will be affected? And most projects will be fine, just accepting that breaking change, but they won't be affected much. Or is it better to like accumulate more stuff and have a bigger change at once? I mean, right now we don't have that many like ideas for breaking changes, or like we have ideas, but not of many of them are like ready to go out in the immediate future. So I think that's something, because we have been focusing on stuff that before 1.0 we said that can wait after the 1.0 release. So it's now stuff that we're doing after 1.0 because it's backwards compatible. And thus we don't need to break anything. I'm really not sure. Like the good idea about having a relatively unpopular, or like Crystal 2.0 with not that many feature changes or breakages would be nice, because you could get rid of some stuff that we don't want, and we could introduce some nice new features. But that's gonna take time, I think, because we're gonna have to make it worth to implement at least a couple of things that are breaking, and we haven't spent really much time on that since 1.0.
I think we all want to change small things in the language that we would have preferred to not have in 1.0, or that we would like to fix in a potential 2.0. Not just removing all the obsolete things, but changing a few things in the language. But I think we need, as Branch said, more explorations into, would it be really worth it to break that? And does it bring something interesting? Does it bring any benefit that we really need to make that change? For now, every time we say something, we say, yeah, it would be nice, but there is no incentive to actually say, yeah, but is it worth breaking everything? So yeah, we need more explorations. And if there are some changes that are not just like, okay, this is a completely different language, and that improves the ability for tooling, that it improves response time, or it improves compilation times, or these kind of details, then yeah, we might think about it. We did improve in pre 1.0 when we introduced the fact that every instance variable has to have a type, either explicit or it's inferred from simple rules. And that was worth it. That really improved things. And it wasn't that disruptive for the language somehow, but it didn't break the language. And it was worth it, and we did make the change. So yeah, we need more explorations and more data, more experience to say, yeah, we can make that change.
One aspect that makes or that I think should be necessary for introducing breaking changes is to make the migration as easy as possible. So that involves having the tooling for that. I think we're now circling back a bit. So are we adding things on our to-do list? Before we can make breaking changes, we need to be able to offer easy solutions for users to deal with them. I think part of the question was also if we intend to drop any features for 2.0. I don't know. I mean, obviously, all the stuff that has been deprecated, usually we deprecate stuff and replace it with alternatives that are better, safer, more efficient, or something. So there is, most of the time, there is a replacement. In some cases, there might not be a replacement. I think for process related stuff like forking, I think that's not even deprecated, but it's never been part of the public API in 1.0. But like these kind of things that we could do deprecations and not replace it with something else. But overall, I wouldn't see much going away from the language, unless we see such a good argument that it enables like tooling or incremental compilation or some big value that we could reach with dropping something from the language.
Good. Well, we still have a few questions in our list, but we've been talking for an hour and so, almost an hour and a half. I'll drop the ones I think are missing, and if anyone wants to pick those, it's fine. Otherwise, we can continue any discussion on the other channels. There was one question about AI and machine learning speed with Crystal, or any plans to get Crystal into that ecosystem. There was another question about moving into another Git server other than GitHub, and a retrospective one about the founder's idea of an ideal language. Have that changed or not? So yeah, it's up to the participants to pick 3 of them or whatever you want.
On the oldest one, the last question from the founder's idea, like I definitely see that my ideal language, like we started with this with wanted to do something different, right? And that idea of ideal language evolved through time. So definitely we today we might have made some different decisions. The current language has some quirks, definitely. Part guilty of those probably, but also like no real language. The only real language that doesn't have quirks are the ideal ones and not the real ones. And Crystal has become a real language. That's good. It's good that we have some things that are it proves that it's being used. So I come to a piece with that. We have talked about some of the things ideas that were unexplored for now. So like the open namespace, finding different solutions to that without losing the ergonomics, definitely. And I have talked to Ari, for example. We still talk with Ari and Juan. So, but I know that, for example, Ari has always been very vouching for more type annotations to get modularity. That's can be seen in the forum and different places, and he still thinks that way. He's more like he likes a little bit more today what Rust offers in terms of tooling and incremental compilation, and he sees that as a fundamental pieces to accomplish that. I hope he's wrong, and there are other ways to accomplish that. But I also, Ari has very clear insight on how things could be more comfortable. Part of the language are his motivations, and there were things that at that point I remember that he say, no, let's not do that, and then I say we should have done that. Maybe that was maybe more disruptive at that time regarding literals and how autocasting should work. Like I wish we should have done that. But on the other side, when we were early days on the Crystal type inference, I wasn't sure how we will handle recursion, and we were able to solve it. And he was more on the side that this has no solution. I think we allow recursive functions to be typed. So I don't know. Sometimes you are on the right side, sometimes you don't, and in the middle you have the different solutions. But yeah, so I think the ideal language has evolved for everybody, and I'm very happy with the current results, definitely. Any other want to pick any other of the questions, or this one also?
I'll pick the one about AI. It's a bit early to say, but I've heard several times that typed languages are having an advantage over untyped languages because it allows the tool to iterate rapidly when it finds a solution, to check that the solution is correct, at least the types are correct. With Crystal, well, we talked long about the tooling and how we need to improve the performance of the type inference. If we have that rapid responsible for a more interactive type checker, and I think the AI tools, they can use that and be guided by the types, and that should be fruitful. But that's applicable to any static, any type check language. So I don't see much difference there. I don't know, and I would like anyone else, if they know the answer to this, if the clean aspect of Crystal, that you see code and it's very clean to watch. I don't know if that's a good thing or bad thing for AI. That I don't know. That's all I have to say about the AI and Crystal at the moment.
The current models are really good at generating Crystal code. A year ago, not so much, but right now they're really good. And I think like Python has cemented itself as the machine learning model training language. I don't think that's going to change, and I don't really see like a big advantage in why Crystal should try to get into that field. Right now, it's all about consuming AI services, and at that, Crystal is just as good as any other language, I would say.
Yeah, I think the main thing I've seen when asking an LLM to generate Crystal code is that sometimes it doesn't do things that are idiomatic, but you can tell it to like to do it a different way, and it will go ahead and write more idiomatic Crystal code. You just have to kind of tell it what the idioms are.
Also, not to mention that the idiomatic way is something to be discovered. Like there are some mediums, like I don't know, implementing network binary protocols. Like you can use some different patterns of writing those, and it's what the Crystal way. Well, it's something to be discovered in some cases. Some are already solved, but there are different ways. It's a different language. They're like the Visito patterns, how we implement it is very different from other languages because you can take the capabilities of the language. So it's understandable that the LLM will not cut all those certainties that there are no examples sometimes.
Yeah, so I was actually talking about some other things, like how you can write a symbol and it will automatically be translated into an enum member. Like it'll try and write out the entire enum member, doesn't matter how deeply nested that is. So it's just little things like that. I haven't seen any real issues with it recently.
Good. So you answered most of them, and now I need to ask: are there any plans for moving into another Git server? That was the only question missing there. Let's answer that one too.
I don't think we have any current plans for that. I mean, the question is about like the source code, like the repository can be quickly moved anywhere. That's super efficient, or doesn't have much cost involved. But the more complex thing would be moving like the project around it, like everything that we use on GitHub, issues, pull requests, CI, all of this. Just changing that has a high cost of just implementing the change, and then whatever comes after the change might be more costly or less costly. Don't know. But yeah, so far we don't have any plans for that. GitHub works. And I think like investing into such big infrastructure changes is an effort that must really pay off very much. Otherwise, it just takes resources from improving other things, and we talked about many things that we want to improve.
Lovely. Great. So looks like we are done with most of the questions. So I feel a bit kind of overwhelmed closing this myself, but I'll try it. Thanks everyone for joining here. Hope you enjoy this meeting. That will be on YouTube for anyone to watch it later, and we can see it many years from now and laugh about what we said, hopefully. So yeah, thanks for being here. It was great. Hope we see each other more often. We can do one of these every less than 5 years, maybe.
Thanks,
good.
Manu, for hosting.
Thanks, everyone.
Thank you all.
Yeah. And
Yeah.
whoever's interested in meeting up after the show, head over to the Discord channel, Discord server voice channel, maybe with beers or snack or whatever is appropriate.
Yeah.
See you there, hopefully.
Cool.
Be there.
Thanks, everybody.
Bye.
Bye.